Hey guys, this video is for pre-cal and this comes from 9.5 and it is called Parametric Equations. So a parametric equation, we are just starting to throw in a third variable called t, and this is called a parameter, okay, that t, and it's just going to introduce time into the situation. So you're going to see that we're going to write x and y as functions of t. So you're going to have an equation for x in terms of t and then an equation for y in terms of t. Now, not to be confused with something you'll learn later on in calculus, that equations with three variables is three-dimensional. This is not a third dimension, this is just time. So for example, in 2 minutes in, how far did the x go right and left and how far did the y go up and down? Okay, so the way we're going to graph this is I'm going to give you a set of t's and you're just going to plug them into both equations. The answers that you get from both equations are going to be your ordered pair for x and y. So take a look at this equation. If I ask you to graph and I give you a function for x and a function for y where t is between -2 and 2, you're just going to make yourself a chart plugging in -2 to 2 into the x function and then to the y function, and then the answers from each of these for the x and the y will be your ordered pairs. I'm going to take a minute and fill these in. All right, so I've gone ahead and set this up for you. -2 squared is 4 minus 1, which is 3, so that's the answer for my x. And then 2 times -2 is going to be a -4. Next one, -1 squared is 1 minus 1 is 0. And then 2 times -1 is -2. 0 squared minus 1, I have a -1. 2 times 0, 0. 1 squared minus 1 is 0. 2 times 1 is 2. 2 squared is 4 minus 1 is 3. And then 2 times 2 is 4. And then now all we're going to do is plot these ordered pairs. So I have 3, 1, 2, 3, -4. Let me scoot down a little bit. Here's my first point. My second one is 0, -2. Then -1, 0, then 0, +2, and then 3, +4. So this kind of goes parabolic. Now, the additional thing we're going to do when we're sketching these for parametric equations is, since time went from -2 to 2, I'm going to show the direction that the graph went as time passed. So if my first point of -2 was down here, the graph kept going in this direction. And you just draw a few arrows to indicate that. Now, anytime I show you a new type of equation, you can obviously always convert it to and from what you're used to seeing, which is an equation that is in rectangular form, okay? So here it's going to be called eliminating the parameter. When I want to eliminate the parameter, it just means I want to eliminate the t and get back in terms of x and y. So the first thing you're going to do is you're going to solve for t in one of the parametric equations. My advice is, if you can catch that one is simpler, use that one. Then once you've isolated t, you're going to substitute it into the other parametric equation. So let's look at this first example, eliminate the parameter. Here in the x equation, I have a t squared and a t. It's going to be hard to isolate the t here. But here I have y equals 3t. Much easier to isolate it here. So if I want t by itself, I can divide the 3 to both sides and say t equals y divided by 3. Now that I have t isolated, I'm going to go ahead and plug that into these two spots. Okay, so now instead of t squared, I could say y over 3 squared minus 2 times y over 3 plus 1. And then all I'm going to do here is clean it. I can say x equals, that 3 is going to get squared. It's going to be 9. So I can say y squared over 9, or I can say 1 over 9 y squared. Minus, I can say 2y over 3, or I could say minus 2/3 y. That's just a difference between putting the coefficient completely up front. And then plus 1. All right, and you're done. Simple as that. Let's take a look at another one. I encourage you, if you'd like, pause the video, try it on your own, and then check if you're able to do so. Now notice that if I choose here, the t is pretty easy to isolate here and same here. So I have two options here. I can do this question completely different than my neighbor and still be correct. I've still eliminated the parameter correctly. It just depends on which one I chose to isolate. So let's show both options. If I choose to isolate this one, I'm going to subtract the 1 over and then divide by 3. Right? Now that t is isolated, I'm going to plug it into the other. Y equals 2 times square root, instead of t, I'm going to put what t was here. And technically I'm done, and I've isolated, I have y isolated, and I have no more t's. I eliminated the variable. The other way I could have done it was isolating it here first. Okay? So here I would need to divide the 2 and then square both sides. Okay? Know that if I square both sides, this entire thing needs to get squared. So t would be y squared over 4. All right, now that I've isolated t, I plug that into the other equation, and I could say x equals 3. Instead of t, I'm going to put y squared over 4 plus 1. Clean that up. I'm going to put 3 over 4. Y squared plus 1. Again, I'm in terms of x and y, and the t has been eliminated. So two different ways to solve this question, both correct, okay? Now, same process, eliminating the parameter, getting everything in terms of x and y, but I have trig functions in here. Things change a little bit. The rules are a little different. Let's check this out. You're going to start first, instead of isolating the t, you're going to isolate the trig function, okay? Then you're going to square both sides. Let's go ahead and just do step 1 and 2 for this first example, okay? If I want to isolate the trig function, I need to divide this 5 and this 2 over. So then I can say x over 5 equals cosine. And then here I could say y over 2 equals sine. Step 2 says to square both sides. Let's go ahead and do this in a different color. If I clean this, I'm going to get x squared over 25 equals cosine squared of t. And then here I'm going to get y squared over 4 equals sine squared of t. Step 3 says to combine both functions. That means I'm going to add them together, okay? So let me draw a line here. And I'm going to put one on top of the other. I'm going to say x squared over 25 equals cosine squared of t. And then I'm going to put the y squared over 4 equals sine squared of t. And we're going to add those two together, okay? When I add them together, when I come up here, I have x squared over 25 plus y squared over 4 equals cosine squared of t plus sine squared of t. Okay? And then step 4 says to use Pythagorean to clean. We remember that cosine squared and sine squared being added together equals 1. So I can clean that up. And now I can clearly see that this is an ellipse. Okay, so if I were to draw this ellipse, I know on the x it would go 5 out to the sides, and on the y's it would go 2 up and down, right? So instead of drawing the entire ellipse, so we said 5, 5, 2, and 2. Now instead of drawing this entire ellipse, let me do it with pencil first. Notice that the domain says to only draw it from 0 to pi. Well, I know my unit circle over here, I start at 0 and go in this direction, and pi stops here, which means I only want to draw this top half and not the bottom half. Now I can erase the bottom half. Okay, and remember I started at the 0, so I'm just going to draw an arrow or two to dictate my direction. And you're done. Let's look at one more example like this. Following the same exact steps. First, isolate the trig function. Step 2, square both sides. Step 3, combine them. Step 4 is to clean using the Pythagorean identity. Okay, so now you may think for a moment that this is an ellipse, but when you go to sketch it, check it out. On the x, I'm going to go out 3, and the y, I'm also going to go out 3. Right? If I'm going out the same amount in every direction, hopefully you start to recognize that this is really a circle. Okay, maybe you're used to seeing if I multiply the 9 to both sides, right, we can also write the equation like this. Okay, so either of these two would be correct. Technically, if you catch a circle, it is better to write it like this. If you're working with multiple choice, it would be written in this format. And because I was not given any specific domain, I am allowed to draw the entire circle. And you're done. Now, for our very last thing, we're going to go the opposite direction. I'm going to create a parametric equation out of a regular x and y equation that I'm used to seeing, okay? Now, this is going to be so easy that you're going to say, okay, what is the trick here? It literally is this easy, okay? All you're going to do is let x represent t and replace it in the parametric equation. Now, granted, there are many different ways we can answer these, and I'm going to show you, but feel free to use the simplest version, okay? Example says, find a set of parametric equations for each of these. Well, if I just let x be represented by t, then I can rewrite y, instead of with the x in there, with a t. And I'm done. I just created a set of parametric equations. This is the simplest version. Now, granted, we could say that I want this whole thing to get switched. So I'm going to say t is going to be x squared. Now that's fine, but know that for parametric equations, I do have to have x isolated. So then I would say, okay, I'm going to square root both sides. X is going to be square root of t. And now in the place of x, I'm just going to write square root of t. And this would be a true statement. You don't have to do that extra step. I just wanted to show you that you have options. Let's go ahead and do the next one. Y equals x squared minus 25. We can be as simple as replacing the x with a t and then putting that t where the x was. We could always get a little more complicated and let the t represent that entire x squared. But then I have to take the extra step of isolating the x, which works out just like the last one. I'm going to square root both sides. And now I'm going to replace the x in this equation with a square root. So I have x, which is square root of t, but then there's a square minus 25, which just made me realize that I forgot to put that squared here. Because again, this square root of t is replacing the x, but this x has that squared. If you ever want to go back and check your work, all you have to do is plug this in, clean it out, and you should get right back to what you started with, okay? Last one. It could be as easy as replacing the x with a t, and then I put that t exactly where the x was. Or I can get a little more complicated and work on replacing that whole thing and say square root of x equals t. Then I have to isolate the x and say that x equals t squared. And then in my equation of y, where I had the x, I'm going to put what x represents. And you're done.